Chapter 8 is all about functions and function notation. So the first thing we need to understand is what function notation is. I'm just going to give you a brief rundown in this video about function notation. So we have this concept of a function having an input and an output. For instance, let's turn on the light, see if we can fix that glare. Okay. For instance, here is a standard function notation, f of x equals y. The x represents our input, whereas the y represents the output. And you can sort of think of a function like it's a machine. So this function is a machine that's named f. Functions, the typical function names are f of x, f, g, h, things like that. The way that we read this whole side, we read it as f of x. It's really common to think that this means f times x, like it's multiplying two variables, but you're not. This stays together all the time. We're not separating these things. When you're dealing with function notation, you have this idea of something called a domain. Oh, sorry. We'll just go with that. Of the domain and the range. The domain is a set of all x values that's in the function. And the range is a set of all y values in the function. Okay. Now, along with these, you also have this idea of an independent versus a dependent variable. If we look at our input versus our output, the output will depend on whatever is input into the machine. So that makes the y the dependent variable. Whereas the x coordinate, or the x value input, doesn't depend on anything else. So your x is going to be, in this case, your independent variable. Common times when we're dealing with function notation in the real world, the independent variable often deals with time, because time doesn't change for anybody or anything. It goes on and on and on forever and ever and ever, whether we're asleep or awake, whether we're at work or at home or whatever that is. So that's a really brief rundown of function notation. Just a last sort of bit of information, when we have function notation like that, f of x equals y, it's sort of another way of representing an ordered pair. If we look at our ordered pair, right, we normally have x, comma, y, which is sort of the same thing that we have here. We have our input x, and then we have our output y, and we have our y. So that's just another thing that we want to sort of use to help us relate this to things that we already know about.